This is the Burj Khalifa, 828 meters tall, 160 floors. That's half a mile straight up into the sky. It's so tall that the temperature at the top is 6 degrees colder than the ground. It's so tall you can watch the sunset from the ground floor, take an elevator to the top, and watch it again. But in 2004, when construction started in Dubai, every structural engineer on Earth said this was suicide. Here, SY building here should have been impossible. Dubai is a desert. Summer air temperatures hit 50 degrees Celsius and the sun heats steel to 80 degrees. At that temperature, normal concrete cracks before it cures. Steel expands and twists. Then there's the wind. At 828 meters, wind speeds hit 160 kilometers per hour. That's a Category 2 hurricane every day. A normal square skyscraper would create vortices behind it like a flag flapping. Those vortices would shake the tower until it tore itself apart. And the foundation. Most skyscrapers sit on bedrock. Manhattan has it. Dubai doesn't. The Burj site is just sand and weak sedimentary rock. How do you anchor a 500,000-ton building in sand? The economics were also insane. Dubai wanted the world's tallest building to put itself on the map, but no one had ever built this high. The budget was $1.5 billion, but if the tower failed, the company and the country's reputation would collapse with it. Chief architect Adrian Smith and structural engineer Bill Baker had to reinvent the skyscraper from scratch. First problem, foundation. Since there's no bedrock, they drilled 192 piles. These are giant concrete columns, each 1.5 meters thick, going 43 meters deep into the sand. Think of them like the roots of a tree. Then they poured a concrete mat 3.7 meters thick. It's the size of a football field and weighs 110,000 tons. That mat spreads the building's 500,000-ton weight, so the pressure on the sand is less than a person standing. Second problem, the wind. If you build a tall square tower, wind slams one side and creates spinning vortices on the other. Those vortices pulse at the same frequency as the building, and the shaking gets worse and worse until it fails. It's called vortex shedding. So Smith borrowed an idea from Islamic architecture. He designed a Y-shaped floor plan like a three-legged stool. The Y shape confuses the wind. No matter which direction it hits, it gets broken up. But that wasn't enough. Every 30 floors, the tower steps back and gets smaller. These setbacks chop the wind into pieces so it can't build force. Computer models showed that without this shape, the Burj would sway 2 meters at the top and crack. With it, it sways only 1.5 meters. That's less than a person's height on an 828-meter building. Third problem, the heat. Concrete normally takes 28 days to cure and get strong. In 50-degree heat, it would lose water too fast, shrink, and crack like dry mud. So they only poured concrete at night when temperatures dropped to 35 degrees. And they added ice, not a little ice. Over 30,000 tons of ice went into the Burj's concrete mix. They also had to pump concrete higher than any building in history, 600 meters straight up. At that height, the pressure in the pipe is 200 times normal air pressure. The concrete would solidify from heat and friction before it reached the top. So engineers invented a new high-pressure pump and added chemical retarders to slow curing. They also chilled the pipes. Each pour was a race. If the concrete sat in the pipe for 30 minutes, the whole line would harden and they'd have to jackhammer it out. Then the cladding. The Burj has 26,000 glass panels. Each one had to reflect heat to keep the building cool, survive sandstorms that sandblast like a pressure washer, and take 160 km/h wind impacts. They tested panels by firing 2x4 wood beams at them at hurricane speed. To clean them, they installed 18 permanent machines that ride on tracks up and down the building. Think window washing robots for a half-mile tall tower. Inside, the problems got worse. Water pressure at street level is strong. At 828 meters, gravity makes it zero. So they built mechanical floors every 30 stories with pumps, tanks, and plumbing. The Burj uses 946,000 liters of water per day. The air conditioning is so powerful that condensation from the system is collected. That water gets used for irrigation. 57 million liters per year, enough for the entire park at the base. The elevators were another world record. The Burj has 57 elevators, and the main one travels at 10 meters per second. That's 36 kilometers per hour straight up. Your ears pop twice on the way to the observation deck. The elevators also have parachute brakes. If the cables snap, the brakes clamp the rails and stop you. Finally, the spire. The top 200 meters of the Burj is not floors you can use. It's a steel spire to claim the height record. That spire was lifted in sections and bolted together 600 meters in the air by workers on harnesses. The spire alone is taller than most skyscrapers. The building opened on January 4, 2010. It took 6 years, 12,000 workers from over 100 countries, and 22 million man-hours. 3 workers died during construction. The final cost was $1.5 billion. Today, the Burj Khalifa uses 10,000 tons of cooling per day, same as melting 10,000 tons of ice every 24 hours. It has its own postal code, and its shadow at sunset is 2.5 kilometers long. The Burj isn't just the world's tallest building. It's a 828-meter-tall proof that with the right shape, the right materials, and enough ice, you can beat the desert, beat the wind, and build a tower that touches the clouds. It says impossible is just an engineering problem waiting for someone crazy enough to solve it. If you loved this, hit like, share it with someone who loves megastructures, and subscribe for more videos explaining how the world works.